In this example, we want to decompose the following expression into partial fractions. To do that, what we need to do is get a couple factors first. So what I'm going to try to do here, and we don't have to worry about the numerator yet here, all we want to do is we want to try to factor x squared minus 9, and that, of course, is a difference of two squares. You're so lucky that you got that, and it's just x plus 3 times x minus 3. Our next task is to figure out something over x plus 3 plus something over x minus 3, and this whole side has to be the same or equivalent to that left side right there. So what we're trying to do is we're trying to split up this one fraction into two, in some cases more, fractions. Alright, well, let's see how to do this. Gosh, if we could only just multiply the left and the right side by this. If we could just multiply by x plus 3 times x minus 3 everywhere. So we'll multiply by x plus 3, x minus 3 here. Sorry if that's running off the screen. It shouldn't be. And then we've got x plus 3 here and x minus 3. And I like to keep everything in parentheses. That helps me identify some factors. So these guys will cancel out. We'll have x minus 27 and x plus 3 and x plus 3 will cancel. So we'll have a times x minus 3 here, and then we're going to have the x minus 3's cancel, and we'll have b times x plus 3 here. Now at this stage of the game, what we need to do is pick good values for x that will allow us to solve for either one of these guys right here. And keep in mind that the final solution, whatever the value of a is, it's going to go over x plus 3. So I'll write maybe a little note for us here. A is going to go there, and then b was over x minus 3. And if you do this in reverse, it's okay, but you should get the same value over x minus 3 and the same value over x plus 3, even if those are flipped. That's okay, or just switched, I should say. So let's see if we can figure out how to solve for a. So we'll put solve for a here. And to solve for a, we want this whole thing over here to go away. So an x value of negative 3 would cause that to happen. So you want this term, or this factor here to be 0. So let's let x equal negative 3. Well, if x is negative 3, that one's negative 3. So negative 3 minus 27 is equal to a times, and that's going to be negative 3 again, plus b times negative 3 plus 3. Negative 3 minus 27 is negative 30. We'll have a times negative 6, and then b will be multiplied by 0, so it's gone. All we need to do now is divide by negative 6. Negative 6 over negative 6 is 1, and a in this case will be 5. So we can actually put that here at the top if you'd like. And then we need to do the same thing, but this time we're going to do this for b. So we're going to solve for b here. I'll put a little squiggly line there for you. We want to look over here at this guy right here, so I'll put some dashed lines around it. This is what we're going to use to find both a and b. Alright, so we want to cancel this entire term out, and this factor needs to be 0 then. So we're going to let x equal positive 3. If that happens, then what will happen with the a term is it's going to be 0, and we'll be able to solve for b here. So let's figure out what this is going to look like. We've got 3 minus 27 is negative 24. We said a times 0 is 0. And we've got b times 6. Well, then we can just divide by 6. And we can see quite easily here that b will be negative 4. So you can write your negative 4 here up in the top. If you choose to make this 5 over x plus 3 minus 4 over x plus 3, that's fine. But essentially what we're doing is just trying to find those values in the top and the bottom so that we can split this up. The original expression has the same value as this expression. You can try to add these fractions together and see if you get back to this one, and you should. They're equivalent expressions. We're just attempting to break them up, break up one fraction into two fractions, or partial fractions, I guess you could say.